right? So we're doing 192.168, we did 20.27/20, right? So just like Aaron said, the 255 and 255 we know because this is a /20. So how many network bits do I have with a /20? Everyone answer, how many network bits do I have with a /20? It's a nice easy question, right? 20. So we know we've got 8 bits that are part of my network because the subnet mask tells me. We've got another 8 bits which are part of my part of my network because the subnet mask tells me. And then so that's 16. Well, I need to get up to 20. So I like what Aaron did where he bit out the third octet, right? He bit out the third octet. So there's 16, right? And then plus 4. So there, now we have 20. Now, do I care at all about the fourth octet? So Pedro, you said no, right? And you're right, you're absolutely right. I don't care about the fourth octet when I'm figuring out the network address. Why don't I care about the fourth octet when I'm figuring out the network address, Pedro?
Because there's 32 bits and you only need 20 for network
Okay, and the rest are all what?
host bits.
Yeah, they're all host bits. So because they're all host bits, what do I do to them?
Uh, just put them as zeros.
Yeah, they just turn them all off because remember we said that the definition of the network address is when all the host bits are what, everybody? All the host bits are off. So in this scenario, I don't even care about the fourth octet because all I'm going to do is turn them off, right? I'm going to turn them off. So in this scenario, right here, I've got a 20, so my network stops there, right? That's where my network stops. So if I were to go ahead, right, and I bit out what that IP address was, right, the 20, that's going to be, oops, see, I did this wrong. This is so if I do the 20, right, that's right here, and if I do my 240, where my subnet mask is, where are my babysitters? Right? So again, what do I know? I know that all of this is part of my network. These are all of my hosts. So my network address in this scenario is 192.168.16.0/20. Okay, so how about you guys do, let's do, oh, actually, I think I have some samples that we can do in the presentation because today we're going to dig a little deeper, right? We're going to go deeper and we're going to learn about the host bits. So we've spent a lot of time working with network bits. Now what we're going to do is we're going to spend a little bit of time and we're going to start talking about the host bits. Okay, we're going to talk about the host bits. So we already know another way to write the subnet mask is with slash notation, right? As an example, 255, 248, I could write that as a /13. We just count up the ones, right? So today what we're going to be doing is we're going to be looking at the host bits, which are all of the zeros, okay? And there's a couple of different ways that we can do that. And so the first thing that I want to teach you is I want to teach you how to write this host table. And we will be practicing this all the time. So I want you to get really good at this. This is going to be like the OSI model where I quiz you about it all the time. So we've already learned how to count by binary, right? We've been practicing 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 48, 4096, 8192. Okay, well now we're going to add another little piece to that, okay? And we're going to look at it in terms of the octets, okay? Because that counting by binary, what that does is it matches up to the number of hosts in a subnet mask. So if there's not, we don't really deal with a /32 subnet mask. Like, as all this time that we've been talking, have you ever seen us talk about a /32? Really, that's just referring to all the bits in the IP address. It just means all the bits in an IP address. Now, also, a 31 is very uncommon. Very uncommon. It can happen, but mostly only ISPs are going to use a subnet mask of /31. Not impossible, but uncommon. But where we really start to see things is with the /30, okay? So what I want you to see is that depending upon the subnet mask, it tells us how many addresses we can get from that subnet mask, okay? So in octet number 1, if we look at this, at the 1, just line that up with a /32, 2 with a /31. So I want you to write this down right now on a piece of paper, and you're going to write down like this. You're going to just write down 1, 2, 4, 8, 16, 32, 64, 128. So everybody needs to write that down. Then next, you're going to just go ahead and write the 32 next to the number 1, the 31, the 30, the 29. Now notice we're just counting down, right? The first column, we count by binary, 1, 2, 4, 8, 16, 32, 64, 128. The second column is just backwards, 32, 31, 30, 29, 28, 27, 26, 25. We're just counting backwards, okay? So everybody should have that written down. Okay, now what you can do is you can keep counting. So next go to, oh, what happened? Just keep counting down, 256. So just keep going, 256, 512, 1024, 2048, 4096. So just count by binary. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. Count all the way down to the 32,768. And just line the subnet mask up with it, right? So here's the next one, 256, 512, 1024, 2048, 4096. 8192, and then you're writing down, just write it down. So I think in the videos I said to practice this, right? So this column represents the number of hosts, okay, that we can get with whatever the subnet mask is, okay? So if I have a /24, well then I have a total of 256 addresses. And I'm going to break this down for you even more. Now I'm going to go ahead and I'm going to show you the third octet and the fourth octet, okay? Oops. But we don't, I mean, we very rarely are ever going to need to go that high. Like a /16 would be 65,534. A /15 would be, let's see, like 136,000. So the numbers just get too big to kind of do it in our head. But it's the same thing, okay? Just doing everything by binary. So at this point, you should have all of octet 1 and all of octet 2 written down. So if I had a network address that was 192.168.0.0/23, what I could tell is I could just look at this chart over here, and this chart will tell me how many total addresses are available with a /23. So in this case, it would be 512, okay? 512. So let's put this into industry terms. So let's say I was starting a new business, and I knew that I was going to have 400 employees, 20 printers, a couple projectors. So I'm just going to guess that maybe I need 500 addresses. And I would call the internet service provider and I'd say, hey, I'm starting a new business. I think I need about 500 addresses. The internet service provider would say, okay, well, here, I'm going to give you the network address of 192.168.0.0/23. Why would they give us a 23? Because the 23 gives us enough addresses so that we could address all of our computers. Okay? Now there's something that's really important to understand about these addresses, these hosts. Okay? These hosts also include the network and the broadcast, which are not usable addresses, right? Every neighborhood, every LAN needs its own network address. Well, the network address is reserved for the network. It cannot be assigned to a computer, it can't be assigned to a printer, it can't be assigned to a server or a projector. All it is it's the network that we all belong to. There's another address that can never be used or assigned. What is that address? So there's two addresses that we have to remove. One is the network, yeah. Aaron, the broadcast address, right? The broadcast address. And then someone tell me, what is the broadcast address used for? Yes, Francisco, Damien, to send data to everybody on our network. So the very, very, very first address, which is unusable, is the network. The very, 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 very last address is the broadcast, and that's if I needed to talk to everybody on the network. So in this scenario that we just had, right, we had I think it was like we did a 192.168.0.0/23, right? That's what the ISP gave us because we told the ISP we needed 500 addresses. So how many addresses do I really have that are available for me to use if they give me a /23? Yeah, so I see a bunch of right answers. It's 510, right? Because I had to remove one because it's already being used by the network. I had to remove another one because it's already being used by the broadcast. Okay, how about this? A company calls you up because you work for the ISP and they say, hey, I'm part of Discover Card. I'm part of Discover Card. And Discover Card is going to set up a whole new department for special customer complaints as it relates, or customer needs as it relates to COVID. And we're going to stock this. We're going to have about 1,000 employees in that call center working in that call center. We're going to have 1,000 employees working in the call center. So what subnet mask size would we have to give to Discover Card if they're going to add a whole new department with 1,000 employees? Okay, so if they're going to add 1,000 employees, right? This would take care of that, right? 1024. So we would need to get a /22 network. We would need to get a /22 network. Okay, now how about this? Petco is going to open up a new delivery warehouse. And at the delivery warehouse, they're going to have a few computers, maybe a server to hold their point of sales. It's not going to, it's going to be a really big location, but they don't have a lot of technology needs. They're going to have 17 devices. So they're going to have 17 devices. So what size subnet mask would they need for 17 devices? So they would need a /27 subnet mask, right? Because if you take 32 and you subtract 2 from it, that leaves 30. So that's plenty to take care of the 17. And look, this would be too small, right? This one would be too small. Do we agree? Okay, how about this one? I am going to hire a couple of data entry people. I just need a couple of data entry people, and each of them are going to have their own computer. So I'm going to hire 4 data entry people, and I need to have 4 computers set up. So what subnet mask would take care of 4 computers? Okay, so I see a couple 30s and I see a couple 29s. So Matthew, can you come off of mute and tell me why you picked a /29? You can't come off mute. Oh, your mic doesn't work. Yeah, just type it in and I'll read it out. So /29 is actually the right answer. And let's let Matthew tell us why he picked a 29. Let's see, you chose 29 because if you have to subtract 2 from the total number of hosts, right, which is 1 for the network, 1 for the broadcast, a /30 would end up only having 2 available. It would actually be too small. Yeah, that's actually right, because I needed 4 total computers. So we have to go to a /29. If I have an 8 and I subtract 2, that leaves me with 6, and I still have enough for my 4 new data entry employees. Okay, so let's do a couple. So this is the easy way to do it, you guys. This is the easy way, and I want you to just get in the habit of every day practicing 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, and then write the corresponding subnet mask right next to it. Like that's just the way you should start every class. You get in class and you write your chart out, okay? When you take the CCNA, you won't be able to use a calculator, and you're not always going to have a calculator available. Not only that, we want you guys to be getting like $60,000 a year jobs and move up to the $75,000 range and the $85,000 range. And ultimately, hopefully we'll all be making 6 figures. Well, if you get into the 6-figure range and the chief information officer comes to you and asks you a question about networking size, and you're getting paid $110,000 a year, you do not want to say to the chief information officer of your company, hold on, I don't really know, I need to use a calculator. You do not want to do that. It's actually more acceptable to just jot this down and to say, oh, let me show you, da 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 da, and then you just show them, okay? But there is another way to figure this out, and it's just using simple math. So remember, right now, we're talking about host bits. So those are the zeros, right? Those are the zeros inside of our subnet mask and our network address. So if I have a 192.168.0.0/24, I have 8 host bits. If I have a 192.168.0.0/23, I have 9 host bits. So we're talking about host bits, okay? So given the network address of 192.168.10.0/24, how many hosts are available? Well, what we do is we count up the number of host bits. If it's a 24, we know that's 8, right? And everything we do is binary. So remember, every value can be represented by either a 0 or a 1. So 2, that's how we get the binary. There's only zeros and there's only ones, 2, binary. So what we could do to figure out how many host bits is, again, we could look at this little chart, right? A /24, I can get 256 minus 2, or I could do this little math trick. 2 binary raised to the number of host bits, I've got 8 host bits, is 256. And then I always have to subtract 2. Why do I subtract 2? Everybody answer in the chat box. Why do I always have to subtract 2 from the total number of addresses? There we go. Yeah, 1 is the broadcast and 1 is the network. So I always have to subtract 2. All right, so how about this one? If I have a network address of 192.168.10.0/23, so first of all, how many host bits do I have with a /23? Host, the actual bits themselves. Right, I have 9. I have 9. So now if I take a look and I do the math, right, I would say 2 raised to the power of 9. Now again, unless you have a calculator, who can even figure that out? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2. It's easier to use the chart. But 2 to the power of 9 is 512. I subtract 2, 1 for the network, 1 for the broadcast. So I have a total of 510 usable addresses. So this is a really important terminology. If you're ever taking a CCNA exam or even just talking to somebody, you have to remember there's a difference between the total addresses and the total usable addresses. Because really, 512 is the total number of addresses, because that takes into account the network and the broadcast. But the total number of usable addresses is only 510. 510. Okay, how about this one? So you guys tell me how many host bits are available. Just tell me the number of host bits first if I have a /12. Yeah. So I have 20 host bits, right? Because there's 32 bits. I have 12 network bits. So 12 minus 32 is 20. So we have 20 host bits, right? 20 host bits. A /12. So here's my 12 network bits, right? There's my 12 networks. Now all of these are host bits, right? Host bits. Now, I would use a /12 if I had a giant business. I'll give you an example. At GCC, we have a 10 network. Well, the reason we have a 10 network is because between all of the Maricopa community colleges, we have thousands and thousands of addresses. So we need a /12, because remember, the smaller the subnet mask, okay, the smaller the subnet mask, the more hosts you have. The bigger the subnet mask, the smaller the number of hosts are, okay? All right, so we've got 20 host bits, so if we did that math, it would be 2 to the power of 20, and that's like a giant number. That's really hard to figure out unless you had a calculator, but you could just do the chart, right? You could just do the chart. All right, so everybody, I want you to send this answer just to Leslie, okay? Send this answer to Leslie. So make it private just to Leslie. I need a network address that can support 600 hosts. Which subnet mask will do that? So you're going to have to look at your table. You're going to have to look at your table. When you get most of them answered, Leslie, just give me a heads up. So you need 600. Okay, so the question is that I need a network address that can support 600 hosts. Which subnet mask will take care of 600 usable hosts? I need 600 hosts on my network that I'm going to set up.
Okay, we have.
Okay, so what was the answer? Someone come and tell me the answer.
/22.
/22, right? Because if I need 600 usable addresses, I cannot use a /23 because a /23 wouldn't be enough. Now, I could use a 21, but I'd be wasting a bunch of addresses. So I want to pick the best fit, which is a /22. Okay, now I could also have done the math, right? 2 raised to the power of 10, 1024 minus 2. Okay, so somebody come online and give me the positional values inside of an octet. What are the positional values inside of an octet? Someone come off mute and give them to me. Oscar, can you come on and give me the positional values, please?
You have 128, 64, 32, 16, 8, 4, 2, and 1.
Yes. And do they repeat in each octet?
They do repeat.
They do repeat. Thank you very much. All right. So this should look familiar by now, right? We've got octet 1, 2, 3, and 4, right? And they repeat. The positional values repeat, right? The positional values repeat. Now, on Monday, I said there's a particular type of network bit that we should all pay attention to. Okay, what is that bit that we should all pay attention to? Yes, thank you, Pedro. Let's get a couple more answers. Not necessarily the octet boundary, not necessarily the boundary of the octet. That's important too, the /24, a /16, and a /8, that's the octet boundary. but there's a particular bit. Yes. So the bit, and again, you all need to write this down, okay? You want to pay attention to where the last network bit is. The last network bit. And the reason is because that tells us the subnet increment. The subnet increment, okay? Because as a network administrator, you're going to be setting up networks. So you might have a LAN A set up for the students. You might have a LAN B set up for the labs. You might have another LAN set up for teachers, right? Or let's think about like maybe, again, a pet store. You might have a local area network set up for all the cash registers because they all belong to like a point of sales system. You might have another network set up for the cameras that are inside of the business. You may have another network set up if you have like a warehouse and delivery. You may have another network set up for a vet center. So right there in one business are 5 or 6 networks, okay? So we want to know how to increment so we can determine what's the next network. So if I have this address, 192.168.20.4/30, what octet is that subnet ending in? Right? It's ending in the 4th octet, right? It's ending in that 4th octet. Now, where does the last network bit fall? Where does the last network bit fall? What positional value? Yeah, it's going to fall on the 4. It's going to fall on the 4. So what this tells me is that if I need to get another network, what I can do is I can take this network right here and I can increment it by 4 in the 4th octet. Okay, so what would that look like? Well, basically, I would just add 4 to the 4th octet to get the next network, 192.168.20. What, everybody? .8, right? .8, because I just incremented it. Okay? So that's why we need to know where the last network bit is, because we need to be able to figure out what the next network is and the next network. Okay, so if I have a /30, how many total host bits do I have? How many bits do I have? Right, I have 2 bits. So then how many usable addresses would I be able to get from a /30? Actual usable addresses. 2. Yeah, exactly right, 2. Because the /30, right, I have these 2 bits, right? I have these 2 bits. 2 raised to the power of 2 equals 4. Minus 2 equals 2. All right, let's do another one. Okay, so 192.168.20.24. So let's figure out the subnet increment. So first of all, what octet is the subnet increment in? So do we all agree it's in the 3rd one, right? It's in the 3rd one. So now, where does the last network bit fall? Where would the last network bit fall? What positional value? Yeah, it's going to be the 1, right? It's going to be the 1. So if my address is 192.168.20.0/24 and I wanted to know what the next network would be, what do I need to do? How do I figure that out? How do I figure out what the next network would be? Okay, so I add 1, and where do I add 1 to? I add 1. So we've got that the subnet increment is 1, but where do I add it? So I've got one right answer. Yep, Pedro, yes. So let's think about this. What octet are we working in? We're working in the 3rd octet. So you're going to add the 1 to whatever octet you're working in. Okay, so in this case, we're going to add 1 to the 3rd octet. So my next network would be 192.168.21.0/24. What would the next network be? What would the 3rd network be? What would the 3rd network be? I only have 2 answers. Right, so I would have to add 1 in the 3rd octet. So then I would have 192.168.22.0/24, and so on and so on and so on. Okay, so how many host bits are there? How many host bits are there in a /24? I have 8 host bits, so how many usable addresses could I get from a /24? Okay, 254. All right, so here's another one. So a /12, a /12. So first of all, what octet does a /12 fall in? All right, do we all agree it's an octet number 2? Okay, now how about the positional value? What will my subnet increment be? So a 12 is the 16, right? It's the 16. Okay, so what would the next network address be? What would the next network address be? So Pedro, we're working in the 2nd octet, right? So we're going to add 16. We add So we add 16 to the second octet. So we have a 10.16.0.0/12. Yep. Okay, what would the next network address be? Yes, right? We add 16 again. So then we have 10.32.0.0/12. How about the next network? I would add 16, right? So I would have 10.48.0.0/12, and you just keep going. You keep going. Okay. So how many host bits do I have? 20 host bits. How many usable does that give me? It's a lot, right? What would the math be for this? What do I do to get the math if we're not using a calculator and we don't have our little table? It would be 2 to the power of, well, it's actually, we got to do it to the number of host bits. So we have 12 host bits, so it would be 2 to the power of 20, and I don't know what that is. It's a lot. It's a lot. ... It's a lot. 2 raised to the power of 20. All right, so here's another one. 172. Yep. So what octet is this in? Second octet, right? What's my subnet increment? Right, it's a 128. What would my next network address be? That's right. So I would need to add plus 128 in the second octet, right? So I'd have a 172.128.0.0/9. And again, this is like a giant network, right? How many host bits do I have? With a /9, how many host bits do I have? I've got 23, right? I've got 23. So again, this is like some big math, right? It would be 2 to the power of 23. Again, I don't know what that is. And then I'd have to subtract 2, right? I'd have to subtract 2. Okay, so let's see. What octet is a /23 in? Everybody should be answering. Okay, so we're in octet 3. How about the positional value? What is the positional value of a /23? Okay. What would my next network address be? What would my next network address be? So I'm going to add 2 in the third octet. So I would have a 172.168.26.0/23. What would the next network be? What would the next network be? And what would the next network be? Yeah, and the next one, right? So you get it? If I needed to come up with 10 networks, we could come up with 10 networks, right? Okay, how many host bits? How many host bits? 9 host bits. How many total addresses? The total number of addresses for 9. Total addresses. So this includes the network and the broadcast. So we could look at our little chart, right? 512. Now, how many of those are usable addresses? 510. Exactly right. 510 are usable. I think we already did that one. Let's see, what is that? Okay. So, 24. Okay. So let's take a look. What is the subnet increment and the number of hosts? So first of all, we need to figure out the network address. Okay, so what is the network address for 172.168.25.10? What is the network address? So you might have to do a little binary here, right? Yeah. So let's find the network. So first of all, if I need to find the network, is the 172 part of the network? It is, right? We know it is because of the 255. How about 168? Do we know that's part of the network? Yeah, we do because it's a 255, 255, 254, right? So we know that 168 is part of the network. So I'm going to go ahead and I'm going to do the 25 in binary just so that we can see it. So it looks like this. That's 25, right? Now, do I care about the 4th octet? Do I care about the 4th octet as it relates to the network? I don't, because it's a 23, so I know everything in the 4th octet. We're just turning it off because those are just host bits, right? So then I've got 255. I've got 255. Let me go. 255. And then, okay, so there we have 16 subnet bits. 17, 18, 19, 20, 21, 22, 23, right? 23. And then this is a 0. Everything else, that's off. So I can tell what's part of my network, right? I can tell that this is what is my network. That's my network. So that's how I come up with 172.168.24.0/23. Okay, so does everybody have that for their network? So our network is a 172.168.24.0/23. Okay, what octet am I in? I am in my third octet, right? I'm in my third octet. What is my increment? My increment is going to be 2. What is my next network going to be? Yep, 172.168.26.0, right? And then we know we have 9 host bits, right? We've got the next network. All right, you guys do this one. So you guys do this one. First of all, you have to figure out the network. Figure out the network address. Yes, that looks right. Yes, Louise. Yes, Aaron. So everybody needs to answer me, send me the answer. Yes, everybody should be answering the network address. I'm waiting for everyone to answer. Yes, that looks good, Francisco. Oscar, that looks good. Chris, that looks good. Okay, so what octet are we working in? This 29 falls in the 4th octet, right? What's our magic number? Oops, that's wrong. It's the 4th octet, right? 8 is our magic number. How many hosts, how many usable hosts can I get from a /29? How many usable host addresses are there? So you could look at your chart, right, and find the /29 and see that the total number is 8. You subtract 2 to get 6. Right, 6. And what is our next network? What is our next network? What is the next network address? Yes, Matthew, that's right. Pedro, check your math or your typing. One of the two. Probably your typing, actually. So remember, what we need to do is we need to add the increment, which is 8 in the 4th octet, right? So I would do plus 8 in order to get my network. So my next network would be 10.63.252.32/29. What would the next one be? Everybody give me the next network. So you add 8 to 32, right? It would be 40. Okay. Okay, let's see. I'm going to skip this one. Let me skip this one. Okay. All right. So let me stop sharing. Let's take, does anybody have questions? Okay. Now, look, you guys, with this stuff, you just have to practice it. I know that sometimes people get it right away, right? You're just like, oh man, this is great. This is easy. And that's good. That's a great thing. However, sometimes you just have to practice this over and over and over and over and over. I'm telling you, when I was learning how to do this, I had to practice it so much, especially because I asked somebody to like show me how they did it. And they did it in a totally different way than I had learned or was learning how to do it. And it totally messed me up. And I was like, ah! And so it like set me back like a week because I had to kind of go back and like, okay, let me learn it back the way I did. So if you're doing great with this and this seems easy, that's awesome. That's so awesome. But if you feel like, man, this is kind of tough and, you know, looking at the octet and da-da-da-da-da, that is totally normal. And this is what I want, and we're going to do some more practice. We're going to keep practicing this, okay? And before we get off the line tonight, at the end of the night, I'm going to give you some stuff to do at home. You have to practice this. And especially like sometimes it'll seem like, oh man, I totally get it. And then I'll give you some homework to do and you go to do it and it suddenly doesn't make sense again. Guess what? That's normal. That just happens. So I want to impress upon you that this is why we have tutors. Like, you know, if you've noticed, we have a lot of tutoring available, unlike a lot of other classes. Well, the reason we have so much tutoring is because we know that this stuff can just hang you up a little bit. So please go to tutoring, come to my office hours. Go to Open Lab. I'm so proud of a lot of you guys are just going to Open Lab and doing your homework there and getting help. So you really just keep doing that and, you know, sticking in there with this stuff. Kind of confused. Yeah, you just need more practice. Totally agree.